In this video, we want to see whether the sum from n equals 1 to infinity of n to the nth over n factorial squared converges or diverges. So the way we're going to do this is by using the ratio test. We want the n plus first term over the nth term. So just plug in n plus 1 into the original series and then divide it by the original series. And so here, basically we're going to, the trick here is to treat these two as one fraction and then these two as another fraction. So we'll have n plus 1 raised to the n plus 1 over n times, or n to the nth power. And then the bottom two fractions, this guy actually goes on the top. So it's like n factorial squared over n plus 1 factorial squared. And now I'm going to break up n plus 1 to the n plus 1 power as just n plus 1 to the nth times n plus 1. And I'm going to factor out the square here to get n factorial over n plus 1 factorial. The n plus 1 factorial is just n plus 1 times n factorial. So the n factorials cancel and just left with 1 over n plus 1. Now, the n plus 1 to the nth and the n to the nth have an exponent of n. So I could just factor that out, and I'm left with n plus 1 over n. At this point, we have 1 over n plus 1 squared, and multiplying that by n plus 1, so the square is going to cancel, and we're going to have 1 over n plus 1. And the next step, we can break up n plus 1 over n as just 1 plus 1 over n. And then we split this up into two separate limits, with 1 over n plus 1 being the second limit. The first limit is e. The second limit is 0. So e times 0 is 0. That means the series converges by the ratio test.